Okay, class, going to be working 8.4 trigonometric identities. And for each of these problems, we're going to be starting with one of the sides and then trying to turn it into the other. So here we go. Tangent theta cosine theta equals sine theta. And so I'm going to start with the left-hand side. And I'm going to rewrite tangent as sine theta over cosine theta. And then times the cosine theta that was already there. The cosines cancel, and we just get sine theta. And that's the right-hand side. And we're done. Okay, that was easy. Going to move to the next problem. So for these, I don't like the way these problems, they want you to rewrite everything. Okay, I see what they're trying to get you to do. I wouldn't worry about all this. I would worry about just being able to do this by hand, because that's what you're going to need to do on the test. So let's go with this next one. I want to show that cosine theta tangent theta plus cotangent theta equals cosecant theta. All right, so I'm going to start on the left-hand side. I'm going to rewrite tangent as sine over cosine. I'm going to rewrite cotangent as cosine over sine. And now I'll distribute cosine through. And when I do that, on the first multiplication of cosines cancel, I just get sine theta. And then plus, and then when I multiply this one through, I get cosine squared theta on top and over sine theta on the bottom. Okay, now what I'm going to do is get a common denominator between these two. So I'm going to put this over 1, and then I'll multiply it by sine theta on top, sine theta on the bottom, so I get the same denominator. And then when I put those together, these two multiply to give me sine squared theta. Then I can use the plus sign here, cosine squared theta, over the common denominator, which is just sine theta. But the numerator is a Pythagorean identity. Sine squared theta plus cosine squared theta is 1. This is 1 over sine theta then, and that is equal to cosecant theta, which is the right-hand side. So that's it. All right, clear this out. Go to the next one. So I'm not checking these because I'm just really just trying to make sure that I can prove the identity. So cosecant theta minus 1 in parentheses, cosecant theta plus 1 equals cotangent squared theta. Okay, so for this, I'm going to FOIL this out and multiply here to here. We've got cosecant squared theta. And then this goes to here, that's cosecant theta. And then here to here, that's minus cosecant theta. Those are going to cancel. And here to here, I get minus 1. So that's what the left-hand side is equal to. Now that gives me cosecant squared theta minus 1. But this is a Pythagorean identity. You can look on your formula sheet. That is cotangent squared theta. So we're done with that one. All right, next one, cosecant squared theta times 1 minus cosine squared theta equals 1. I guess you could distribute that cosecant squared through, but I'm going to use the fact that the Pythagorean identity, I know that 1 minus cosine squared is just sine squared. That's what it is. And then I'm going to use the fact that cosecant squared theta is really 1 over sine squared theta, because cosecant is 1 over sine, and then you're squaring it, right? So that just cancels out, you get 1, and that's the right-hand side. Okay, verify this one. So negative sine squared x plus sine to the 4th x equals cosine to the 4th x minus cosine squared x. All right, so I'm going to start with the left-hand side and see if I can turn it to the right-hand side. And since this all has cosines in it, I'm just going to rewrite this in terms of cosines. So remembering that sine squared x plus cosine squared x equals 1. If I solve for sine squared x, I just move the cosine squared x to the other side. So anytime I see sine squared x, I can replace it with 1 minus cosine squared x. So this becomes minus, and then the sine squared here becomes 1 minus cosine squared x. and then I have plus. Now this is going to become sine sine to the fourth x is the same as sine squared x squared. So I'm going to put 1 minus cosine squared x. That's sine squared x. That's this. But then the square here. Okay, distribute the negative through. I get negative 1 plus cosine squared x. And then when I FOIL this out, okay, this really means 1 minus cosine squared x times 1 minus cosine squared x. I FOIL, I get 1 minus 2 cosine squared x minus 2 cosine squared x, and then plus cosine to the fourth x. So that all goes right here. So I have plus 1 minus 2 cosine squared x minus 2 cosine squared x plus cosine to the fourth x. All right, we've got the ones cancel. And then, let's see, is that right? Let me see, what am I missing here? Plus cosine squared. Oh, you know, I don't know where I got those twos from. Sorry. This is a 1. I was thinking ahead. This is 1, 1. That's going to be a 1 and a 1. My apologies. So now when I put these together, I have 1 cosine squared x. That's going to cancel with one of those. No, hold on. Cancels with one of them, and then I still have one left. So I have that left and that left. So that leaves me a cosine of the fourth x minus cosine squared x. Okay, there we go. That's the right-hand side. All right, next one. So 13 cosine squared theta plus 14 sine squared theta equals 13 plus sine squared theta. Okay, so how can we do this? This is a little tricky. Watch this. 13 cosine squared theta plus 13 sine squared theta plus sine squared theta. So what I'm doing is I'm rewriting 14 sine squared theta as 13 sine squared theta plus sine squared theta. And now if I look at just these two, they both have 13 in them. I can pull a 13 out. Be left with 13 cosine squared theta plus sine squared theta, and then plus sine squared theta. And then cosine squared theta plus sine squared theta, that's a 1. So this just turns into 13 plus sine squared theta, and that's the right-hand side. And so we are happy. Okay. Clear that out. All right, we're going to establish this identity. 1 minus sine squared theta over 1 plus cosine theta equals cosine theta. So what I'm going to do here is I'm going to get a common denominator. So I'm going to look at this 1 over 1. I'm going to multiply the top and bottom here by 1 plus cosine theta. 1 plus cosine theta. So the top becomes 1 plus cosine theta, but then I have this minus sine squared theta all over the denominator, which is just 1 plus cosine theta. Okay, now I want this all in terms of cosine. I know I have a Pythagorean identity. I can rewrite sine squared theta as 1 minus cosine squared theta. We've done this a few times now. So I'm going to rewrite that as minus, and then in parentheses, 1 minus cosine squared theta. See, that way I have nothing but cosines in this expression. And hopefully things get better here. If I distribute, I get a minus 1. So 1 plus cosine theta. Get a minus 1 and a plus cosine squared theta all over 1 plus cosine theta. The ones cancel. And so I have cosine theta plus cosine squared theta over 1 plus cosine theta. In the numerator, factor out a cosine theta. And these cancel and you're left with cosine theta, which is the right-hand side. Okay, 1 plus secant v over 1 minus secant v is equal to cosine v plus 1 for cosine v minus 1. All right, so I know that my final answer, I need cosines in this. And in this one, I have secants. And I know secant is 1 over cosine. So I could rewrite this like this. So that's the left-hand side. And now the clever trick. I'm going to multiply the whole top by cosine v, bottom by cosine v. And what happens is here to here, you get cosine v. Here to here, the cosines cancel, you get plus 1. The bottom, you get cosine v. And then here to here, the cosines cancel, you get minus 1, and that's the right-hand side, and we're done. You're probably sitting there thinking, it's a lot easier watching me do it, but this is after many years of doing this sort of stuff. So it's hard to teach the intuition. Intuition just comes with time and practice. Okay, so here we go. This one looks pretty bad. Okay, so over here, let me see what I want to do here. I'm debating between common denominator or turning everything in terms of sine and cosine. Let me go with common denominator. Okay, so I'm going to multiply this top one by 1 minus secant theta, or 1 minus secant theta. And then over here, I'm multiply this fraction by tan theta over tan theta on the bottom. Okay, so my left-hand side, when I multiply the top two together here, those two multiply. I'm not going to show it, but you have to FOIL this. You'll get 1 minus 2 secant theta plus secant squared theta. That's this FOILed out. And then minus these two multiplied, so minus tangent squared theta over, okay, our common denominator, which was tangent theta, times 1 minus secant theta. All right, does anything get better here? Well, yes, I see something. 1 plus secant squared theta, or you know what, let me do it this way. Let me rewrite tangent squared theta. Okay, so we have a Pythagorean identity that says tangent squared theta plus 1 equals secant squared theta. So you know what, I'm still trying to decide if I want this all in terms of sine or cosine. I mean, sorry, tangent or secant. I'm going to do everything in terms of secant. So I'm going to replace this tangent squared theta with, let me see, if I take 1 away from both sides here, I replace tangent squared theta with secant squared theta minus 1. So this is going to be replaced with, in parentheses, secant squared theta minus 1. And then the minus sign goes through. So I have 1 minus 2 secant theta plus secant squared theta. Then when I distribute my minus, I get minus secant squared theta, and then I get a plus 1. All of that over tangent theta, and then 1 minus secant theta. Let's see, this and this cancel, which leaves me on top. The 1 and 1 come together. I get a 2 minus 2 secant theta over what's on the bottom, tangent theta. And then I have 1 minus secant theta. And since the numerator, they both have a 2, I can factor a 2 out. And on the bottom, I have 1 minus secant theta next to that tangent, and those two cancel. You get 2 over tangent theta, but anytime tangent's in the bottom, you can bring it to the top as cotangent. So just, yeah, that's it, 2 cotangent theta. That's the right-hand side. So that was a little more involved. And I'm only halfway. All right, so cosine theta over cosine theta minus sine theta equals 1 over 1 minus tangent theta. All right, so I'm gonna start with the left-hand side. Here's something real tricky. I know I need a tangent down here and I have a sine over here like this. If I had a cosine under this, then that would be tangent. So watch this trick. I'm gonna do 1 over cosine here, 1 over cosine here, and then multiply it through. So watch what happens. Here to here, I get a 1 over. Here to here, the cosines cancel, I get 1 minus. And then here to here, I get the sine theta over cosine theta. And that's exactly tangent theta. So this is going to turn into the right-hand side. Yeah, that's tricky, huh? All right, 1 minus sine theta over 1 plus sine theta equals tangent theta minus secant theta squared. So let's start with the right side. Let's start with the right side. See if we can turn it into that. So if I start with the right side, I'm going to go ahead and just take tan theta minus secant theta and multiply it times itself. So I'm squaring it. Okay, when I go here to here, I get tangent squared theta. When I do here to here and here to here, I get minus 2 secant theta tangent theta. And when I do here to here, I get plus secant squared theta. Okay. What now? What now? What now? Let me turn secant squared theta using the Pythagorean identity. That is 1 plus tangent squared theta. And then I still have tangent squared theta minus 2 secant theta tangent theta. And then plus that thing here. Okay, so what happens now? I can move this tangent out to the front, plus 1. Yuck. Do not like where this is going. I don't like where this is going. Good, this is the first problem where I'm going to start over. Try something a little different. How about this? How about just taking this right-hand side? Let's start out by rewriting sine theta over cosine theta. That's tangent. Secant is 1 over cosine theta. I see it now. Okay, now look. These both have the same denominator, so I can put them together. Sine theta minus 1 over cosine theta. And then I still need to square that. So if I square the top, I'm going to get sine theta minus 1 times itself. And then over the bottom squared is cosine squared theta. Now, before I do anything else, I'm going to rewrite the bottom. There's the top. And rewrite the bottom as 1 minus sine squared theta, because that's the Pythagorean identity. And then I'm going to rewrite the bottom as a difference of squares. Yeah. Because if I rewrite the bottom as a different squares, I get 1 plus sine theta, 1 minus sine theta. And look, these almost cancel. These are almost the same thing. So what I'm going to do is I'm going to take this right here. I'm going to factor -1 out and make this negative sine theta plus 1. And now it cancels here. So on top, I have a -1 in front of sine theta minus 1. And then on the bottom, I still have that 1 plus sine theta. And now if I distribute this through, I'll get a negative sine theta and +1. So it's, oh, sorry, I said that wrong. I'll get a negative sine theta and a +1. So I'll have a 1 on top and a minus sine theta. And on the bottom, I still have the 1 plus sine theta. That's the other side. Yeah, that's tricky. That's tricky. That's tricky. Okay, this is going to have to be it for now. I've got some things I need to do. So I'm going to stop this recording.